Imagine the cloud, a place where humanity stores its memories, its conversations, its businesses, its knowledge, its future. Most people picture something weightless, something floating, something virtual, something detached from physical reality. But that picture is wrong. The cloud is not in the sky. It is on the ground, built from steel, concrete, copper, silicon, water, and electricity. Lots of electricity. Every search, every video, every AI conversation, every financial transaction, every digital interaction travels through a physical machine somewhere, hidden from view, buried behind security fences, protected inside windowless industrial fortresses. Most people see a digital civilization. Few understand the industrial civilization beneath it. Because the internet is not floating in the clouds, it is sitting inside giant data vaults. And those vaults are beginning to reshape the physical planet itself.
History remembers civilizations through their infrastructure. The Romans built roads. The British built ports. The Americans built highways. The digital age built data centers. Every era creates a foundation layer, a hidden system that makes everything else possible. Today, that system is computation. Companies appear to sell software, streaming services, cloud platforms, artificial intelligence. But beneath every software business sits a physical infrastructure business. Because computation is not magic, it is manufacturing. Electricity enters one side, digital capability exits the other. The process appears invisible, yet the machinery behind it has become one of the largest industrial expansions in modern history. Entire regions now compete for access to data centers. Governments negotiate energy policies around them. Investors deploy billions into them, not because they are glamorous, but because they are essential. The modern economy increasingly runs on computational capacity, and computational capacity requires physical infrastructure.
For decades, the digital economy seemed limitless. More users, more software, more platforms, more data, more growth. The assumption was simple. If demand increases, technology will scale. But a hidden constraint is emerging. Not inside the software, inside the infrastructure. Because every new AI model, every new cloud service, every new digital platform requires something increasingly difficult to obtain: power. And the world is discovering a reality few expected. The next battle for technological dominance may not be fought through algorithms, it may be fought through electrical grids.
Every data vault operates through three critical systems: power, compute, cooling. Miss one, everything stops. Power arrives first. Massive electrical feeds move energy from generation facilities into transformer networks. Without uninterrupted power, the digital world disappears instantly. Then comes compute. Thousands, sometimes hundreds of thousands, of advanced processors executing calculations continuously, day and night, year after year. Finally comes cooling, the least discussed, yet often the most important, because modern chips generate extraordinary amounts of heat, and heat is the enemy of computation. Industrial cooling systems move enormous volumes of air and water simply to keep machines operational. This is why data centers increasingly resemble industrial factories, not office buildings. Their purpose is not to house people. Their purpose is to manufacture computational output at scale, continuously, relentlessly, without interruption.
Most people assume technology companies are software businesses. In reality, the largest technology companies increasingly behave like infrastructure companies. They acquire land, secure energy contracts, build power connections, invest in cooling technologies, negotiate with utility providers, construct private networks. The objective is not software. The objective is capacity, because capacity determines scale, and scale determines dominance. This creates an important shift in perspective. The cloud is not merely a technology product, it is a form of digital real estate. The most valuable locations are no longer only city centers. They are places with affordable energy, reliable infrastructure, strong connectivity, and favorable regulation. In many ways, the digital economy has recreated a familiar historical pattern. The most powerful organizations control the foundational assets, not merely the consumer experience built on top of them. Civilization appears digital, but its foundation remains physical.
Every system eventually encounters a bottleneck. For data vaults, that bottleneck is heat. More users generate more requests. More requests require more processors. More processors consume more power. More power creates more heat, and heat creates limitations. The challenge becomes increasingly complex. Electrical grids face additional strain. Water resources face higher demand. Infrastructure expansion becomes slower and more expensive. The industry often describes this as an energy problem, but energy is only the visible symptom. The deeper issue is architectural capacity. Can physical systems support exponential digital growth? Can cities absorb the infrastructure requirements? Can nations generate enough power? Can data centers continue scaling indefinitely? These questions are no longer theoretical. They are becoming strategic economic realities. Many people believe technological revolutions are driven by innovation alone, but history suggests something different. Innovation creates possibility. Infrastructure creates reality. Ideas can spread quickly. Infrastructure scales slowly, and that difference creates leverage. Eventually, every successful digital platform reaches the same destination, the physical world. The conversation shifts from software features to land acquisition, energy procurement, grid access, cooling efficiency, and capital deployment. The winners are not always those who build the smartest applications. Sometimes they are those who secure the strongest foundations, because digital growth ultimately depends on physical capacity, and physical capacity is finite. The greatest lesson hidden inside the data vaults is surprisingly simple. Wealth often accumulates beneath the visible layer. Consumers see applications, investors see platforms, builders see infrastructure, and infrastructure is where leverage compounds, because every digital service depends on something deeper: a foundation, a support system, an engine, a structure capable of carrying increasing demand. The stronger the foundation, the greater the scale it can support. This is why understanding infrastructure matters, not only for engineers, but for anyone trying to understand the future of wealth creation. Because beneath every digital empire, there is always a physical architecture making it possible. Most people focus on the screen. Few study the infrastructure behind it. Most people follow the application. Few follow the architecture. But systems reveal what appearances conceal. And beneath every digital experience, something physical remains, quietly operating, continuously expanding.
relentlessly supporting civilization. Because technology may feel virtual, but scale is physical. And those who understand infrastructure often understand the future first. This is Nexera, decoding systems, architecting wealth.